Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about the one of advanced material, which is carbon nanotube. First of all, let me introduce our team member. The first one is Hafid Nabil, second Muhammad Faiz, third Dani Hakimi, fourth Hafizuddin, and me Muhammad Zatullah. So, what is carbon nanotube? Carbon nanotube is a small cylindrical carbon structure made out of graphene. The tube comprises hexagonal structure. Despite their very small size, carbon nanotubes are very strong. They are currently used for structural reinforcement in applications such as concrete rebar, but could also be used as semiconductor.
Processing of carbon nanotubes. Carbon nanotubes can be synthesized using different methods. Among the most common are arc discharge, laser ablation, and chemical vapor decomposition. The production of carbon nanotube with high purity and uniformity, low cost, and at a large scale is still a major concern of the scientific community and the industry. First method, laser ablation. In this method, a graphite target is vaporized by laser irradiation under a flowing inert atmosphere at temperature near 1200 degrees Celsius. The laser vaporization produces carbon species which are swept by the owing gas and accumulate on a water-cooled collector. Single-wall carbon nanotubes, remarkably uniform in diameter, can be produced when the graphite target is doped with a small number of transition metal such as nickel and cobalt.
So next is arc discharge. In this method, DC plasma is generated between two carbon electrodes under an inertial atmosphere as depicted. As the anode is consumed, a soft fibrous disposed containing carbon nanotube and other carbon particle is formed in the cathode. To achieve single wall carbon nanotube, the electrodes are deposited with a suitable catalyst. So the tube produced by this method are usually tangled and of varied length and diameter.
In this method, a carbon-containing gas is decomposed on a substrate in the presence of catalyzed metal particle at high temperature, 600 degrees Celsius or higher. The lower temperature used in this method reduce production cost. In addition, the deposition of catalyst on the substrate allows the formation of novel structure. Properties of carbon nanotube. Their mechanical tensile strength can be 400 times greater than steel. They are much lighter than steel, with a density 1/6 that of steel, and have greater conductivity than diamond. They are heavier than compared to their length, with an aspect ratio larger than 1000. A tip surface area that is close to the theoretical limit. Each empty core may be filled with different nano material, insulting protecting them from the outside environment.
Structure of carbon nanotubes. First of all, single wall and then multi-wall. First, single wall carbon nanotubes. Three alternative shapes of single wall carbon nanotube may be produced: armchair, chiral, and zigzag. A graphene layer seamlessly rolled into a tube. Then, multi-wall carbon nanotube. A concentrate arrangement of single wall carbon nanotube is multiple layer of graphene seamlessly rolled into a concentrate tubular structure. The last part of this slide is performance of carbon nanotubes and interrelation. The first one, carbon nanotube has strong mechanical, electrical, and excellent electron transport capabilities, demonstrating that the creation of carbon nanotube or polymer nanocomposite might help to broaden numerous application areas. Then, it is necessary to address the shortcomings of this nanocomposite, including their lack of stability, solubility, selectivity, and poor interfacial adhesion between carbon nanotube and polymers. Next, in the aforementioned technique, the monomers and carbon nanotubes are combined by addition of condensation process. Lastly, other techniques for creating carbon nanotubes or polymers include latex technology, melting and blending, and easier solution mixing. For a brighter future, more user-friendly and effective techniques must be created. Thank you.